Hello, class. Today we're going to start Chapter 5, Trig, Identities, and Equations. 5.1 is called Trig Identities. What is, well, we know what trig stands for. Trig stands for trigonometry, sine, cosine, tangent, and all that. What's an identity? Well, just like the word says, an identity is like an equation where the left side equals the right side. Okay? When we see the identities, they'll make more sense. But that's just it. They're just equations where both sides are the same. So we already know some identities. We've seen these identities before. The reciprocal identities. Remember, sine goes with cosecant, etc., etc. These are it. So here are all 6 of them. Let me point to the first 2, and then I won't read the other ones. I'll just read the first 2. One identity says sine theta is equal to 1 over cosecant theta. Right? So what that's saying is that this side comes out to the same answer as this side. For example, pick an angle, any angle. How about, I don't know, pi. Sine of pi, right? Hit that on the calculator. Sine of pi equals, you get an answer. Then if you do 1 divided by cosecant of pi, hit equals, you get an answer. Those answers will be the same. So whether you use this or this, you get the same answer. They're identical. That's why they're called identities. That's one way to look at it. The other way to look at it is you can replace one with the other. If you ever see sine theta, you can replace that with 1 over cosecant theta. Or the other way, whenever you see 1 over cosecant theta, you can replace it with sine theta because they're identical. That's why they're called identities. And then, of course, if this is true, then this follows, right? If cosecant of theta is 1 over sine theta, then sine theta is 1 over cosecant theta. They go together, okay? And then for, just to expedite things and not take forever, what we do when we write the identities is we kind of skip the name of the angle or the symbol for angle. We can leave out the theta or the x because we only care about what the identity is. So these are all the 6 reciprocal identities. Some more identities. There's quotient identities, and the reason they call them quotient identities is because you have a quotient here, this divided by this. One quotient identity is tangent equals sine over cosine. Very common, very popular. It is used very often in this chapter. That is definitely one you're going to see a lot of. You're going to see some of all of them, but this one you're going to see a lot of. And of course, cotangent, since tangent and cotangent are reciprocals, is cosine over sine. Excuse me. Again, identity. So pick an angle, like 45. Tangent of 45 equals, you get an answer. Sine of 45 divided by cosine of 45 equals, you get an answer. The answers are going to be the same because they are identities. Okay? So whenever you see tangent of an angle, you can replace it with sine over cosine. Whenever you see sine over cosine, you can replace it with tangent because they're the same. And these are the same. Okay, so let's do a couple of examples. Let's start off with a very easy one. We're going to use identities. If cosecant of an angle, if cosecant theta is 7 over 4, then what would sine of theta be? Right? Well, we don't want to do this, right? We don't want to do inverse, right? Do the inverse button and use and find what theta is, and then once you know what theta is, do sine of the angle. Okay? We're going to use identities. Well, if you look at our identities up here, we know that sine of theta is really equal to 1 over cosecant of theta. The identity says so. Okay? So if I'm looking for sine of theta, I just need cosecant of theta. When I do have that. In fact, that's why I chose this identity, because it connects, it hooks up these two together. That's the identity that hooks up these two. Okay? So now, let me put in 7 over 4 here. So I get sine of theta equals 1 over 7 over 4. And if you know your pre-algebra, 1 divided by a fraction, you turn the fraction upside down and multiply. So 1 times 4 over 7 is 4 over 7. Okay? I used identities to find the answer. Okay, let's look at another example. If I tell you that the cotangent of an angle, cotangent of x is 2 over 5 square root of 5, and the sine of an angle is square root of 5 over 3, then you should be able to tell me what is the cosine of the angle. Now, do we have any identities that connect all 3 of them, or at least 2 of them? Look carefully at all the identities we saw. Yes, we do. If you look at cotangent, it connects or is equal to cosine over sine. So guess what I'm going to do? I'm going to replace cotangent with this number, sine with this number, and then solve the equation to find cosine x. That's exactly what I did. Right? Cotangent is 2 over 5 square root of 5. I don't know cosine x. I'm looking for that. And sine x, right? Sine x is square root of 5 over 3. Where did I get this? This was an identity that everybody knows. And now you do too. So now we need to solve. This is an equation. How do you solve this equation? Well, I need to cancel this. So I'm going to multiply both sides by square root of 5 over 3. Right? Multiply both sides by square root of 5 over 3. The square root of 5 over 3 cancels. Right? So I just have cosine of x is equal to this multiplication right here. And if you look carefully, the square root of 5 cancels. Square root of 5 or square root of 5 cancels. So I'm left with 2 on top and 3 times 5 on the bottom. So the answer is 2 on top, 3 times 5 on the bottom is 15. 2 over 15. I found cosine x. That was the question. Find cosine x. But I used only identities. Okay? Some more identities. There's lots and lots and lots of identities in this chapter. We are not going to do all of them, but we are going to do many of them. Here are some more identities. These are called Pythagorean identities. And you can see why. Because it's kind of like squared plus squared equals squared. Right? 1 squared is 1. So this one on the left here is used a lot. Sine squared plus cosine squared equals 1. But these you might see too. Okay? One thing before we get to examples using these, one thing I want to say is that you should be able in your head to rearrange this. Right? If you know that sine squared plus cosine squared equals 1, then doesn't it follow that sine squared is equal to 1 minus cosine squared? Right? Go back to this. If I do minus cosine squared on both sides, then I'll get sine squared is equal to 1 minus cosine squared. Right? And the other way, if I do minus sine squared on both sides, don't I get this? So my point is, when you see this or this, you should know that all 3 of these are the same identity. Trig function plus trig function equals 1, or trig function equals 1 minus the other trig function, or the other trig function equals 1 minus the first trig function. Right? So you should know they go together. So if you see this, you know right away that's equal to this. Okay? All right. Let's get to the examples. All right. Use identities. If I tell you that the tangent of an angle is equal to -8 and the sine is greater than 0, the sine of that angle is positive. Actually, I should put theta here, huh? Sine theta is positive. Greater than 0 just means positive. We don't want to write the word positive, so we just write greater than 0. Okay? Then you should be able to find the cosine of theta and the sine of theta. Let's do A first. All right, I'm ready. So, do we have an identity that connects or hooks up or relates, right, tangent and cosine? No, we don't. We do not. Not the Pythagorean identities. So you look up and down, which one can we use? And now keep in mind, if you don't know which one to use any one you like. As long as you write down an identity, you will get correct answers. It's just that some people might get to the answer quicker than you because they see certain identities that work better than others. Okay? So what the book did was they used this one because they know secant is really 1 over cosine. So if we can find secant, we'll just flip it over and it'll be the cosine. Right? So write down the identity and write down what you know. Well, we know tan theta is -8, so we get this, right? Tan squared theta is -8 squared, right? So I'm going to find secant squared theta. That's 64 plus 1, which is 65. Okay, but I'm not looking for secant squared, I'm looking for cosine. So let me go to secant. This is secant squared. Let me go to secant and then flip it over. So I need to take the square root of both sides, right? Square root of both sides. Square root of secant squared is secant. So remember, when you square root, it's plus or minus, 2 answers. So now that I know this is secant, I can say that 1 over cosine, remember the reciprocal identity? Secant is the same as 1 over cosine is equal to this. But I don't want this, I want cosine. Well, flip it over. Right? Cosine is equal to 1 over square root of 65, plus or minus. Right? Don't lose the plus or minus. Okay? And we're going to rationalize that. Remember how we rationalized? Copy the denominator on top here, and then erase the radical sign from the bottom. Right? Remember that? So that's rationalized. I'm done. Not quite. You are not done. Because this is, let me fix it up. You're not quite done because this is 2 answers. Which one do we take? We never had a trig of an angle come up with 2 answers. Is it positive or negative? Well, we know that the tangent is negative and the sine is positive. So what would cosine be? Do you remember all students take calculus, that rule? So everything is positive in this quadrant, sine is positive in this quadrant, tangent is positive only in this quadrant, and cosine is positive in this quadrant. So where are we? We want tangent to be negative and sine to be positive. Isn't that here? Sine is positive, tangent is negative. So we are here, right here. So which do we take? Well, since you want the cosine is negative here too. So we take the negative answer. Did you get that? How do you know when to take the positive or negative? You figure out, let me fix this up. You figure out which quadrant you're in by the information you're given, right? Remember how this goes. All students take calculus. Everything is positive. Sine is positive, but tangent and cosine are negative. Tangent is positive, but sine and cosine are negative. Cosine is positive, but tangent and sine are negative. Do you remember that? So according to this information, I need to be negative for tangent and positive for sine. This is the only place. So I am here. So what is cosine, positive or negative here? It's negative. So I choose a negative answer. All right? All right. Let's do B. Find sine theta. Now here, we could have gone a long way and used, well, maybe you could have used this one because this is related to sine and this is related to tangent, and that's what we have, tangent, and we're looking for sine. But what the book did was go back to the quotient identities. Do you remember this one? Tan theta is equal to sine over cosine. Right? That was the previous page. In fact, you could have done that here too, huh? But any identity you choose has to fit your information. And if you look at this one, it fits it, right? I have tangent, and I'm looking for sine, and I have cosine, because we just did it. Okay? So, let's replace tangent theta with -8. There it is. With -8. There it is. And let's replace cosine theta with our answer, negative square root 65 over 65. Right? Cross multiply, right? Imagine a 1 here. Imagine a 1 here. So sine theta times 1 is sine theta. And the -8 times this is -8 times this. Right? Let's do the multiplication. Let's do the math. Sine theta is equal to positive, right? Negative times negative is positive. 8 square root 65 over 65. Nothing cancels. We're done. That's it. Sorry. Negative times negative is positive. And 8 times this fraction is this. Nothing cancels, so I'm writing the whole thing. Right? I found sine theta. That was my question. Find sine theta. Okay? The key to all these problems is to start with appropriate identities that relate what you're looking for with what you're given. Okay? That's what we're doing here. We're not really using calculators here. Okay? So let me flash the notes one more time and then leave you with a couple of try problems for tomorrow. Okay. So we started with talking about what an identity is, and we said that we already know some identities, the reciprocal identities. We've seen these before. Wait, there we go. There we go. And then we have more identities. There's 2 more called quotient identities. Then we did a really simple example. And then we did another example. Right? And remember, all these start with one of the identities that we know. And we plug in the numbers and solve. And we solve just like equations. Right? And then we saw even more identities, Pythagorean identities. And you're supposed to notice that these are the same as this. And we did 2 examples. Again, we started with an identity. Substituted the numbers and solved like an equation. There was a reason why we chose the negative. We talked about what the reason was, why we chose the negative answer. Then we moved on, because now we have cosine, so we can use this identity. I know tangent from the given, and I know cosine because I just did it. So I replace those numbers and do the math. And that's it. Okay, So the try problems I'm going to leave you with are like the first example. Okay, we'll do some like the second example tomorrow, but let me leave you with these two problems, and we'll start tomorrow with these two problems. Okay, that is 20 minutes and about 15 seconds. That's not bad. All right, see you all tomorrow. Good night.